Concerning the late stages of the evolution of stars like the Sun, the low mass stars, we want to look at the HR diagram and see that, first of all, we have temperature here, luminosity here, so the brighter stars are here, lower, fainter stars are here, the hotter stars are to the left and cooler stars are to the right. And the main sequence consists of stars that are high mass here and lower mass, and the Sun is located about right here. Lower mass than the Sun is down here. And when all of the hydrogen is extinguished or exhausted in the core, because all the hydrogen is converted to helium in the core through the process of nuclear fusion, the star must then change, and the star transitions and follows the red giant branch and becomes has a helium flash when the core fusion of carbon into carbon, helium into carbon, begins at the helium flash. The time after that is called the horizontal branch, and you can see that it's horizontal on the HR diagram. Low mass stars become dimmer but hotter, so they're moving to the left and down, first down and then to the left on the HR diagram. And different mass stars will do different things, but they will all do more or less the same thing, except the highest mass stars, the shortest lives, have a different end to their lives than the lower mass stars. So we're going to concentrate mainly on the lower mass stars, and especially on the one solar mass or solar-like stars. So on the main sequence, we have a hydrogen burning core, and around it we have outer layers with no reactions, no thermonuclear reactions taking place. All of the fuel and ash is being used there in the core of the hydrogen burning core and the helium ash that is created there. And so when all of this runs out, the only place that there's fuel is in a shell surrounding the core of the star. So there's a helium core, no thermonuclear reactions here, and a shell where the nuclear reactions are occurring. Outer regions, no reactions taking place. Now, keep in mind that the core is very, very small compared to the star, especially in the red giant stage, because the core is shrinking and the star is expanding outward. Then after the helium flash occurs, the red giant star, after helium burning begins, the fusion of helium into carbon is taking place in the core. So this blue region in both places, there is the core, but in this case there's no thermonuclear reactions, but in this case that's where the reactions are taking place. There's also some reactions taking place in the shell surrounding the core, but in the horizontal branch, it's not written here, but this is the horizontal branch star, the nuclear reactions are taking place in the core and predominantly, but also somewhat in a shell surrounding the core. And the reactions are hydrogen into helium in the shell, but helium into carbon and some oxygen in the core of the star. And so that is the horizontal branch star. But eventually the helium runs out in the core. This is very similar to what happened on the main sequence. Remember, on the main sequence we have the Sun here. The Sun doesn't move up and down the main sequence, but the Sun remains on the main sequence for billions of years as it's converting hydrogen into helium. And we see that we can look at the not not just the 90% of stars that are on the main sequence, but we see that there's giants and supergiants and white dwarfs. And so the focus of the video here will be to see how these other groups and regions get populated in the diagram. And so we saw that in the red giant branch, here is a diagram of the first ascent of the red giant branch, and the star expands so much that it engulfs Mercury. It will engulf Mercury in nearly Venus's orbit and not the Earth, but the inside, deep in the core, there's helium, pure helium, hydrogen being converted into helium in the shell surrounding the core. This is the red giant star. And then the horizontal branch, the star then becomes much smaller because we saw that it moved off away from the top right corner in the HR diagram, smaller than Venus and Earth. Mercury is now gone. Hydrogen is converted into helium in a shell surrounding the core. And the main source of energy, the thing is helium converted to carbon in the core itself. So the horizontal branch is much like the main sequence in that there is core fusion. Now after the helium gets all fused, then the star has to make another transition, and that is to the asymptotic giant branch star. And for obvious convenience, we usually call this AGB. And the AGB is the second red giant branch, and that is that once, like on the main sequence, you run out of hydrogen in the core. Here on the horizontal branch, you run out of helium in the core. The star expands and comes way out, maybe even out to the Earth's orbit, certainly to past Venus's orbit. The star then has a complicated structure, almost like an onion skin, where you have carbon in the core, helium converted to carbon in a shell around the core, hydrogen converted to helium in another shell surrounding the core. So the shells don't go away, but the new fusion is taking place in here. So once this becomes pure carbon, you end up with this, and you have a conversion of helium to carbon in the shell. And so the hydrogen converted into helium in the AGB shell here, it is there, but is no longer active.